Hello students, in the previous videos we discussed the section that the concentration of all the species involved in the electron reaction is unity. This is not be always true because there are the reaction in which the concentration is not to be unity. So we need to write an equation that is called as Nernst equation. That is, let us discuss the Nernst equation in this video. Nernst equation for an electron reaction. How we can write the Nernst equation? The Nernst equation showed that the electron reaction, this reaction in which there is a gain of n number of electron, so the Mn to Mn positive is converted into M, where n positive, that is the charge on M. Let this is a general equation. So the electron potential of any concentration measured with respect to the hydrogen electrode can be represented by the equation, that is Nernst equation. This equation, that is E is equal to E naught value minus RT by NF ln concentration of M with respect to the concentration of M n plus. Here something which is written in the bracket sign, that is representing the concentration. So this is the Nernst equation for this electrode reaction which is shown here. When the concentration of the solid M, that is the metal, is taken as 1 here. Here you can see in this equation the concentration of M is taken as 1. Then the equation changes into in this way. That is E naught minus RT NF ln 1 by M, concentration of Mn plus. Now we can see that the concentration of M is taken as unity. So the equation will become here, that is the Nernst equation for this electron reaction is given here. Now we'll be writing this equation here, that is the Nernst equation for that reaction. Let us in this discuss what are the terms which we are using here. That is R. R is the gas constant. Its value is known to us. That is 8.314 joule per Kelvin per mole. Here F is the Faraday's constant. Its value is 96500 coulomb per mole. Here the concentration is represented in this way. That is the concentration of the metal ion, that is represented here, concentration of M, and the total number of electrons gains or lost, that is equal to the number N here, which can be represented here as N. So these are the terms from this. The T term is representing the temperature. Thus in this equation R is representing the gas constant. Its value is 8.314 joule per Kelvin per mole. T is the temperature, that is taken as 298 Kelvin. N is the number of electron either lost or the gained. And F is the Faraday's constant. Its value is 96500 coulomb per mole. And the concentration of the ion is represented here. So for a general equation, if we write the general equation in this way, that is A plus B is giving rise to C plus D. Now here small a is the stoichiometric coefficient of the reactant A. The small b here, that is the stoichiometric coefficient for the reactant B. Similarly here C is the stoichiometric coefficient for the product C, and the small d is the stoichiometric coefficient of the product D. So here the stoichiometric coefficient is very important because to write the Nernst equation. So the Nernst equation for this equation can be represented in this way. That is E cell is equal to E naught cell minus RT by NF ln Q, where Q is the what we have learned last year, that is the concentration of a product with respect to their stoichiometric coefficient in the power divided by the concentration of reactant with their stoichiometric coefficient in the power. That is what we learned last year in this chapter, that is in the equilibrium chapter. Now here So Q value substituted here. So we got the E cell is equal to E naught cell minus RT by NF ln concentration of C to the power C, concentration of D to the power D by concentration of A to the power A into concentration of B to the power B. Now this is the equation after substituting the value of R, because R is a constant value. T is the value that is a constant we have kept here, and F value. After substituting this, when we solve this one, we get an equation that is a Nernst equation. Now this is the final equation which you have to learn, that is the Nernst equation. How we find out the E cell, that is EMF of the cell, by using this equation, that is the Nernst equation, that is equal to E naught cell. How we find out E naught cell? Naught cell means a standard value, that is a standard reduction potential of cathode minus anode, that will give rise to the E naught cell, minus 0.059 by N log of concentration of C to the power C into concentration of D to the power D divided by concentration of A to the power A into concentration of B to the power B. So this is the Nernst equation. So it is very important to learn this equation. So for this equation, the general equation, the Nernst equation which you have to by heart, that is this one. While doing the problems, it is important to have the Nernst equation. Better to learn the Nernst equation by using this general equation. Now we'll be taking the example of a particular equation, that is the case of a galvanic cell. We are familiar with this equation, that is Zn plus Cu2 plus giving rise to Zn2 plus Cu. Here, when we keep the case of a general equation, that is A, this we have already taken in the form of a overall equation. This one is A, this is B, this is C, and this is T. This is what we have learned the general equation in the general equation, and we'll be applying that equation here for writing the Nernst equation. That is E cell is equal to E naught cell minus 0.059 by N log of, we have to remember concentration of product by reactant, that we have to learn here, and the stoichiometric coefficient should be in the power. So it is very important how to write the Nernst equation, that is E cell is equal to E naught cell minus 0.059 by N log of concentration of the product divided by concentration of the reactant. Since here this one is a metal, so its value is unity. This one is a metal, its value is unity. So we need only the ions here. So concentration of charged ions are required. Which one is on the product side? That is product, on the product side is zinc ion. So that will come in the numerator side, and the what we have in the reactant side, that comes in the denominator. So how you will be going to learn? That is concentration of the product divided by concentration of the reactant. That is why the zinc ion we are writing on the numerator side, copper ion in the product side. So whenever a overall equation is given to you, you can write this much of part will be together, that will be same, but the n value changes, that depends upon the equation, that is how much number of electron is lost or gain, that is in the balanced equation, that value is n here, and the concentration of product by concentration of reactant. This is what actually you need to remember for writing this equation. So whenever the equation is given or the cell is given, better to convert into the overall equation. This is the overall equation, that is what the redox reaction. So always try to convert the cell representation into the redox reaction, and you apply the formula of Nernst equation. Example 3.1. Now here the question and the answer both is given. So look at how it is done here. Represent the cell in which the following reaction takes place. Here the reaction is given instead of cell representation, and it was asked to write the cell representation. So here Mg plus 2 Ag plus is giving rise to Mg2 plus twice Ag. So here we have to write this in the Nernst equation form, and in order to find out the E cell, because the question is asked to calculate E cell, that you can see calculate E cell if E naught cell value is given to us, that is 3.17 volt. Now how we do this one? First we have to write the cell representation, and the method of writing the cell representation is already discussed in the previous video. So how we write this one? Because the oxidation part will comes on the left hand side, and on the reduction side that comes on the right hand side. So here oxidation, you can see Mg is converted into Mg2 plus. That means the oxidation is taking place, Mg converted in Mg2 plus, that is what written Mg bar Mg2 plus, and the concentration of Mg2 plus is given to us, that we are writing in the bracket of Mg2 plus. Next is the separating the two part, that is by salt bridge, double line you have to make here. Next what we have to write the reduction half cell. Reduction half cell where the reduction is taking place. Now look at here, Ag plus is converted into Ag, that is positive charge. Now it becomes zero charge here, that is decrease in the oxidation number, that's a reduction. So here reduction Ag plus is converted into Ag. So that is what it is written, Ag plus bar Ag. And the concentration of Ag plus is given in the problem. So that we have to write in the bracket here. So this is the cell representation. Now how to write the Nernst equation? So for that, better to use the formula, that is general equation, that is E cell is equal to E naught cell minus RTNF ln concentration of product by reactant. So after solving the value, after putting the value of R, T, F and all, we have learned this equation, that is the E cell is equal to E naught cell minus 0.059 by N log of concentration of product by reactant. Now look at here, concentration of reactant which is on the reactant side, that is the concentration of product by reactant we have to write. What we have on the product side, that is Mg2 plus. So that value we have to write in the numerator. So that you can see, that is written in the numerator by concentration of reactant. What we have in the reactant side, that is Ag plus. Here the concentration of Mg and concentration of Ag is taken as unity. So no need to look at that, only look at the ions here. So which one is ion? Mg2 plus ion, that is in the product side. It should be written in the numerator side, and what we have in the reactant side, the ion is Ag plus, that's concentration should be written in the denominator, that is the product by reactant. And don't forget to write the powers, that is the stoichiometric coefficient. Now look at here, in the case of Ag plus, that is 2 Ag plus, that's the stoichiometric coefficient is 2 here. So there should be a power 2 here, that you can see 2 is the power written here. And when we look at the case of Mg2 plus, that is 1 Mg2 plus, that is stoichiometric coefficient is 1. That's why the power of concentration of Mg2 plus is 1. So it is important to have the stoichiometric coefficient, then only we can write the powers, otherwise the question will get mistake. So we have substituted the value of E naught cell. E naught cell value is given to us, that is 3.17 volt. So 3.17 volt minus 0.059 by 2. Now why it is taken 2 here? N is equal to 2, because when we find out here, the 2 electrons are lost by Mg and the 2 electrons are gained by the 2 silver ion. Therefore the N number is equal to 2 here. So that is in the denominator we can see 2 log of concentration of product by reactant. So that value is given to us, concentration of product 0.130, that is written in the numerator, by concentration of reactant, that is 0.0001 m, and here square is there because 2 Ag plus is there. So when we solve this one, we will get the value 2.96 volt. So it is important because the question on the Nernst equation are very important. So all of you practice well on the problems of based on the Nernst equation. So this is all about this video. Have a nice day.